Okay, we should be live again. Let's see. OBS is working, my microphone is working.
Optimizing data types. Sometimes the default data types used by pandas can consume more memory than necessary. You can specify lower memory data types when reading the data.
It's a huge delay. Yeah, if I'm not responding to you something, that's because there's a huge delay. Even if I hit live button, oh no, it's actually not that bad. It's like playing up. Yeah, the delay between what I say and YouTube live stream can change quite a bit. So apologies for that. Hit the link. Right, just share this just in case. Just in case someone wants to join in. We got this tool that GPT-4 made for us in pretty much no time. Let me see. So we're loading 10,000 data points from this file. Sorry, my voice is super annoying, but it is what it is. So we want to make sure we're loading the correct data. So this one's still loading stuff. It's crazy. Need to like log in again or something. I think it's getting some errors maybe. Yeah, I think it's getting a lot of. Oops, everyone meant to see that stuff. That we tried at GitHub from IG. The Python, it didn't actually work, so we might as well close that. Currently just using a text file because we exported the data before. Not sure, I think I have to log in again. Let's see. Yeah, just log in again. Find datasets. List the 9 items. We'll open this one here. So it's I of 4. There are 2 of them. One is much longer. Yeah, look at this one. So that document doesn't work. It's okay because we're after the time series. That's where it's loading that data from. It's having trouble getting a lot of errors. There's a cookie. Why is there a cookie? It's monitoring my browser type. Yeah, that's okay. So what we're trying to do is confirm that this data is loading correctly. Might let it run for a while. Something's still happening. Well, we have the 16 channels. The sampling rate is 400 hertz. By the way, yeah, this data is from the Mayo Clinic, United States of America. So that should be top-notch data. Well, it is top-notch data because this EEG is from an implant. Still loading there. So this is where the data is coming from. Don't know what's up. That's it. You have 8 channels on the left, 8 channels on the right, 16 all up. Don't have a description for this, the PDF that doesn't work. Pretty sure I had it somewhere saved, but don't actually need it. It's pretty straightforward. The other thing that isn't straightforward is that this file has annotations. Supposedly when seizures occur, and that's what we need for trading and stuff. Need those annotations. I don't have them displayed. I don't think I even have them in the file. And the other thing is just pop it on our screen. To see when it quite finish loading. Still loading. We have this data open here as well. There's just something isn't right about it. No, I mean, it probably is correct, but still need to double check. So the other good thing is, yeah, this file is loading in the browser, so that's good. GPT-4 made it for us. Would I be later able to turn this into a web application and host on Apache server using Flask? I want to share it pretty much straight away. That's what I'm getting at.
Yes, you can indeed turn this into a web application using Flask and host it on an Apache server. Here's a general outline of the steps you would take to create a Flask application that displays your plot. Install Flask. Install Flask in your Python environment using the following command: copy code pip install Flask. Create a Flask application. Create a directory for your Flask application and create a file named app.py, or another name of your choice, in that directory with the following contents. Create an HTML template. In the same directory, create a folder named templates, and inside this folder create a file named plot.html with the following contents. Run the Flask application. You should then be able to access your application at http://127.0.0.1:5000/. Run the application by executing the following command in your terminal. Deploying to Apache. You can find more detailed instructions on deploying a Flask application to Apache with mod_WSGI in the Flask documentation.
Yeah, that's actually great. We might as well go for this. What's this bootstrap? That was a bit odd. Sorry, my other screen is distracting. It's the one I just used to monitor my stream. Install Flask. We have Flask installed. Yes, we want an app.py. This should be in the main folder. This bit. Just do this just so we can see better. Some 100 stuff. Need a folder called templates. We have done this before, haven't we? Be professional at this. Not really. What's this called? Plot HTML, whatever, doesn't matter. We need an HTML file for our Flask application. To save that, go back to the app. We run this. Yep, it's running, but why did you remove? Looks like you removed some stuff. Removed some stuff. That's no good. Why did you do that? Don't do that to me. Yeah, we're loading 1000 and this should display 100, but the rest of the file should still be there. And let's see. Let's actually just change change this from how to turn this into a web application using Flask. Get the Apache server for now. We want to turn it exactly to a web application using Flask. Let's do this again. Yes, if you step. Yes, we have Flask installed already. That's okay. Create a Flask application. Yes, we have the app. Python. This is render template string. Number of points. Yeah, that's what we were missing before. A defining function called plot. It's reading subset of the data, should be 1000 points. And print the number of columns. Okay, we don't have to do it, but take it out later. Update access. Yes. PO2 HTML. Looks legit. Okay. The HTML is actually embedded inside here. Why? Okay. So we don't have a separate HTML file. Just copy this because it works. Yes, we'll use this because it has that 100 stuff. Should have just updated. Right. So this is better. Just double check. Ah, that won't run again. No, that's just the one off. This one should be just sitting there for good. By the way, the EEG.org is still loading the time series. Something must be really wrong. Is it still doing stuff? Yes, it does. It's getting something from this server. It's just it is a large data set, but it's been running for quite some time now. Okay. This one is looking much better, isn't it? I can compare the two. Well, once it's loaded, we can do a quick comparison. We actually should do a quick comparison because theirs should be more accurate because that's the original implementation. But this one is definitely way faster. If it's not doing the speed on the website, don't use it. So thank you, ChatGPT, for making this for us. Just quickly go back to the original thing. Oops, I think I shouldn't have. Oh, no. This is the one loading the whole file. Abort. Right, this is the... Okay, now I'm confused. Doesn't matter, we don't need that anymore. We have this one. And that stopped working, of course. Okay, where is it? It's this one here. Should start again. So initial display of 100 points, that's correct. We have, let's see, 100 points all up. Okay, a couple of things. Should we put the HTML file code into a separate file? Also, the window on the page is narrow. Can we make it scale to the window size?
Absolutely. Having the HTML content in a separate file is a cleaner and more organized approach. Moreover, to make the plot scale to the window size, you can update the figure layout to have responsive sizing. Create a directory named templates in the same directory where your app.py is located. Inside the templates directory, create a new file named plot.html and write the following HTML template to it. In this template, we've added bootstrap to the head for some basic styling. This is optional, and added a style block to make the plot container take up the full height of the window. Update the plot function in your app.py to use the render_template function to render the plot HTML template and to set a responsive layout for the plot. Now, your plot should scale to the window size, and the HTML template is in a separate file, making your code cleaner and more organized. Save the changes and rerun the app with Python app.py, and you should see the updates.
Okay, is this the whole file? What's the size? That's great. Just starting, so can't get worse than what it is. Still in debug mode. Right. Sorry for that. It's working. Okay, we need to deal with those edge cases. Sweet that it's opening like that to begin with. A minor issue, but it's not scaling to begin with when page is loading the first time. Also, can we have some margins from top and bottom? Could you actually generate a CSS file?
Certainly. To ensure that the plot scales properly when the page is loaded for the first time, and to add margins at the top and bottom, we can make some adjustments to the HTML and CSS. Create a directory named static in the same directory where your app.py is located. Inside the static directory, create a new file named style.css and write the following CSS to it. This CSS adds a padding at the top and bottom of the body and centers the plot container within the page. The plot itself is given a max width to prevent it from becoming too wide on larger screens, and its width and height are set to 100% to fill the container. Update the plot, HTML template in the templates directory to link the CSS file. This template now links to the CSS file, which styles the page and the plot. In the Flask application, app.py, set the plot's height to 100%.
Okay.
Save your changes and rerun the app with Python app.py. You should see that the plot scales to the window size when the page is loaded, and there are margins at the top and bottom of the page.
Something isn't quite right, but that's okay. So the thing still, it's still loading. Ooh. Takes some time, doesn't it? So I want to be able to display about 10 seconds as default. Change the Python code. Can we change the Python code? The sampling rate for this data is 400. We would like to load 1 minute worth of data and display 10 seconds to begin with. So the scroller is 10 seconds and we can scroll over 1 minute. Actually, we don't need a variable for this because this will be hardwired. Okay, 24,000. How about we start? Do we need 1 minute? So I have points per second, duration to load, loading 6 minutes, duration to display. Right, so that should replace pick update. It seems legit. And we can just test it. Refresh. X-axis is displaying something else. Okay, I want to also split. Okay, there's a few things. I think it's this hidden. Can we correct a few things? First of all, the label above the chart is not displaying properly. It's half hidden. Can we also change the x-axis to display time? Deleted the first sentence that I said, but it's okay.
Absolutely. To display time on the x-axis, you first need to create a time series that corresponds to your data points. Given your sampling rate of 400 Hz, or 400 samples per second, you can create a time series that starts from 0 in increments by 1/400th of a second for each subsequent data point. You can then use this time series as the X values in your plot. Here's how you can modify your script to do this.
That's why it's not keep generating the whole code. Some other days, like yesterday, it would never do this for me. I don't know if it's only the code is crossing like 100 lines of code or something, then it would not generate the whole thing.
In this script, I added a time series column to the data frame with a frequency of 2500 microseconds, or 1/400th of a second, using PD, data_range. This time series is then used as the X values in the plot. The initial range of the X-axis is set to the first 10 seconds of data using the initial and final timestamps of that range. The time series makes it easy to set the initial X-axis range in terms of time rather than the number of data points. In this script, I added a time series column to the data frame with a frequency of 2500 microseconds, or 1/400th of a second, using PD, data_range. This time series is then used as the X values in the plot. The initial range of the X-axis is set to the first 10 seconds of data using the initial and final timestamps of that range. The time series makes it easy to set the initial X-axis range in terms of time rather than the number of data points. The error occurs because the time range I used in the PD, date_range function is too large, causing an overflow error when converting to nanoseconds, the internal representation of date time in pandas. To resolve this, we can instead create a time series using a time delta range which will prevent this overflow. Here's how you can do it. In this modified version of your script, I used pd.to_time delta to create a time series from a range of values divided by the sampling rate, which should prevent the overflow error. It also allows us to directly specify the unit of time, s, per seconds, which matches your data's sampling rate. In the script I provided, the x-axis shows the index of the data points, which essentially represent the time in terms of sample points, given that you have a constant sampling rate. This is a straightforward way to plot the data without converting to actual time units. However, to make the plot more intuitive, you might want to convert the index to actual time. With a sampling rate of 400 Hz, each data point represents a time interval of 1400 frac 1 400 4001 seconds. You can convert the index to time in seconds as follows. Now, the x-axis will represent time in seconds, and it will start at 0 and go up to 60 seconds for 1 minute of data. The initial display range will be 0 to 10 seconds to display 10 seconds of data initially. This makes the plot more intuitive and easier to interpret, as you can directly see the time in seconds on the x-axis.
Cannot format Python files. Format document. What's happening? Okay. Have this bit. Right, so that's showing 10. This should be showing 60, so that's correct. I don't know what it was hallucinating. Something else before. Okay, we only got 15 minutes or so. Let's check. Yeah, this one's still loading. Maybe there's something wrong with that specific data. I'm pretty sure it's okay because I was using it before. All right, this one's loading fine. It's like, what? Stop that. Check the file name. That's definitely A02. Right. Okay, I did something incorrectly before. Sorry. 04, 02, day or 1. That's the file. Let's have it about the same size. let's display 10 seconds. Okay, let's do another thing. We would like the option of separating the channels so they are not overlaid. So we want the channels to be visible one on top of the other, but remain within the same graph. Let's see if it understands.
To plot the channels one on top of another within the same graph but without overlapping, you can modify the data frame before plotting to create a gap between each channel. This way, each channel will be displayed at a different vertical level, which will prevent them from overlapping. You can achieve this by adding an offset to each channel before plotting. Here's how you can do this.
It's generating the whole code. Pretty sure I would assume it's only because the code is under like 40 under 50 lines at the moment.
In this script, an offset is calculated based on the difference between the maximum and minimum values of the entire data frame, and this offset is applied to each channel. This will separate the channels vertically, preventing them from overlapping and making it easier to visualize each channel individually, while still displaying them on a single plot. Adjust offset _ step is needed to get a satisfactory separation between the channels.
Well, like that one working well. This one will have separation between channels, supposedly. Start. Yes. It's working okay. Okay, that bit looks like this. So what's up with the labels? So part of 5, we have this. So that feature is this one here. I don't know why is it all seem to be mixed up. Yet that bit is right of 5. That's 0, 1, 2, 3. Yeah, it's the mapping of the channels. I don't actually know what it is, but set that channel. And let me restart this. So why? Yeah, I want to be able to scale the whole thing. Why doesn't the window scales vertically? It's only a narrow box in the middle of the browser.
The vertical scaling issue might be occurring due to the default settings of the plotly graph or the HTML and CSS setup of your web page. The plot is confined to the dimensions specified in the plotly figure layout, which is controlled by the height parameter in fig update_layout function. To make the graph scale vertically with the browser window, you can try setting the height parameter to a percentage of the viewport height using CSS in your HTML template. First, remove the height parameter from fig update_layout in your Python script so that it looks like this. Next, in your HTML template file, plot HTML, you can add a style to make the plotly graphs container take up a certain percentage of the viewport height. Here's how you might structure your plot HTML file. In this template, a container div with the ID plot container is created to hold the plot, and its height is set to 80% of the viewport height, 80vh. Adjust the percentage as necessary to get the desired vertical scaling. The width is set to 100% to make it span the entire width of the browser window.
Now let's now adding the styling in the HTML. Okay, we got 9 minutes, 8 minutes. So in the Python code should be fairly straightforward. Yes, we don't want to change the height. That suffice, you think? No, it's even making it even narrower. Okay.
Next, in your HTML template file, plot HTML, you can add a style to make the polygraphs container take up a certain percentage of the viewport height. Here's how you might structure your plot HTML file.
Instead of the HTML file, shouldn't we just modify the CSS? Could you regenerate the CSS file?
Absolutely, I understand you want to modify the styling of the web page using an external CSS file. Here's how you can create a CSS file and link it to your HTML template to style the plot container. First, create a CSS file. Let's name it style.css in the same directory where your plot HTML is located. In style.css, add the following CSS to style the plot container. Next, modify your plot HTML file to link to the style.css file. In your Flask app structure, it is conventional to put static files like CSS in a folder named static. Your Flask directory.
So I already have a CSS file. Eventually, we want a button to be able to
The
either
existing CSS you have styles the body to center its content and have a minimum height of 100% of the viewport height, 100vh, and gives it a gray background. The plot container class is styled to have a white background, some padding, a maximum width, and a centered margin, while the iframe is styled to take up the full width of its container and have a height of 600px. If you want the plot container to scale vertically to take up most of the viewport height, you can modify the plot container and iframe styles to use viewport units, VH, for the height. Here's how you might modify the CSS. In this modification, the plot container takes up 80% of the viewport height and the iframe takes up 100% of the plot container height, so it will also be 80% of the viewport height. Adjust the 80vh as necessary to get the desired appearance. Remember to correctly reference the plot container class in your HTML where the plot is being embedded. Here's an example of how your HTML might look. Note that I used class equals plot container to match the class selector, plot container in your CSS.
right. Why to begin with it's this one's okay, HTML is okay, it's called the CSS. Have the text at the top here, then we'll sort it out later. bit like losing context already. Oh, come on. Okay, we only have
Your
5
HTML structure is well
minutes.
structured, correctly linking to the external CSS file and embedding the plot within a div with the class plot container, which is styled in your CSS. The viewport meta tag is also correctly set to make your web page responsive. To meet your earlier requirement of displaying 10 seconds of data initially within a scroller that allows browsing through 1 minute of data, you'll need to adjust your Python script where you handle the data and plot generation. Given the sampling rate of 400 Hz samples per second, you can calculate the number of samples as follows. 10 seconds of data, 10 seconds asterisk 400 samples per second equals.
Get it. It keeps forgetting the code. You have to keep reminding it. One must have the CSS because it just generated it. Like, problem is when you load this page, it's loading like that, and then it becomes larger all of a sudden. The current problem is that the page is loading as a narrow window, and when you start scrolling through the file, then the web page scales. Can I just say bye-bye? Like 3 minutes, 2 minutes till the end. See you next time.